Hello, thank you for coming. My name is Valdemar Quevedo, but you can call me Wally. I will be talking to you about about monitoring NATS. So a little bit about myself. I recently joined Apcera a couple of months ago. Before joining Apcera, I was at Rakuten, which is a big e-commerce website in Japan. And so I was there. We were one of the early adopters of Cloud Foundry, and Cloud Foundry was all built for its control plane. It was using NATS. I mean, in those times it was using Ruby NATS. So that's how you became familiar with doing operations and maintenance operations around NATS, mostly the Ruby NATS server. But for this demo, we'll be using the gnatsd, which is like the high performance Golang written version of the server. So for those of you, so first, how many of you are familiar with NatStop? Yes. OK. So for those of you that are not familiar with it, the gnatsd server has a special monitoring flag that you can pass to the server. And it will be exposing a monitoring endpoint. So depending on your background, you will be familiar with the naming used. So it's so this is using we have a public available endpoint, which is demo.nats.io. So if you target it and go to port A222 /C, you can see some general information about the server and how many cores it has, memory it's using, the uptime. So this one was started like 20 hours ago. And you can see more information about the connections that these are connected to the server right now. So one of the very cool things about NATS is that it is a plain text protocol. So we can just, it is completely feasible to just type it out, the protocol in the telnet connection. So we'll be doing that as an example, demo.nats. And I encourage you to try it if you want as well. So I can just telnet into demo.nats.io. So here now I have a single connection. So I just refresh the page. You can see it there. So I will make a very simple subscription. I mean, it's like case insensitive, just sub foo1. You can see it someone else connected. And so I can send query parameters to check out which are the subscriptions that I have right now. So I have a single client right now subscribed to foo. So in real time, you can check what's going on with the server. And so I'll send one message, foo, 2 bytes. OK. So I'm getting this. I'm sending to myself via NATS a message. And it is doing all of this accounting for you, the server. So you can see that you can confirm that it's one message being sent and 2 bytes so far, right? In and out. So, OK, so this just to show how simple is the protocol, and I will be rather than making this server work, I will start one locally. So let me see if I have my. OK, so I just open a screen session. And in order to expose this monitoring endpoint, so the flag is -m. So by default, it's using the port 8222. So here we have the latest version that was just released a couple of days ago, 06.6. And I will do the same and just create a small client. It's a very simple client, telnet-based client, which is connecting to it. But first, I will start NatStop. OK, so here's NatStop. So this will be basically polling information from the monitoring endpoint, like periodically. And I start polling information from a local host by default on the port 8222. So this is like basically gives you this very simple UI which you can use to monitor what's going on the server. So I will connect to it. You can see that it becomes reflected in the server, and there's this connect op that you can we use to be able to label each one of the clients. We use this to know like which is the version, the runtime from the client, and which version of the client is it using. So just for demo purposes, I will give like a dummy label demo. Yeah, demo version 1.1. Okay, so now the server is aware of the the client. And I will make one simple subscription, once again, through one. So now I can see that I have a single subscription here. And if I go to NATS top and I press S, so I can toggle the subscription that I have right now. So everyone can see this? It's okay? Yeah. So let's make another one, bar 2. So it becomes reflected there. And send a couple of bytes. Help. Yeah, so this is, well, this is the most basic usage that you can have, but you can see that how we're tracking everything, and now I'll start more interesting clients. So I have a list of clients here that are sending 1,000 messages per second with a 1 byte or 1 kilobyte payloads, and other one that are using the request response pattern that you can use on top of NATS to be sending 1 kilobyte payloads of 1,000 requests. So I will start one of these. Sorry. Okay. Shut this down. So I will start sending. I will start from 1 kilobyte. A single client sending 1,000 messages per second of 1 kilobyte. So this is how like the UI reflects this the work that gnatsd is doing. So I will add more clients. Let's say some 10 messages per second, 1 kilobyte. Okay, so I will close this screen here. So you can see we have 10 clients in total sending around 10,000 messages per second, 10 megabytes per second. And this is, gnatsd is still basically in idle mode, right? So it's not doing a lot of work. Let me check quickly if I... So I can start, I will add one subscriber right now. Let me split the screen once again. So basically we have 10 clients publishing events, 1,000 messages per second. And we can see that we don't have any traffic going out, right, to any subscribers. So if I create one single subscriber, basically all those events will be sent, consumed by a single worker. So you can see now that I'm sending 10,000 messages per second, and just a single subscriber is consuming everything, right? So this means that if we create more of these, let's say 5 of these, we will have 5 times the traffic that we are sending in the clients, right? So we can, I'm using parallel wrong here.
Once the message gets consumed, does it get blocked from the message queue? Once it gets consumed by a particular client message, does it get dropped from the message queue, or still it remains?
It's, yeah, basically the subscriber is receiving the message.
Yeah, already received the message, so it is dropped from the message queue.
It's
consumed and it's gone.
yeah. Okay.
And can you specify IoT, this is very relevant.
Uh-huh.
What kind of events you're trying to subscribe to? Can you subscribe for particular patterns of events?
Yeah, you can create this the
It's a wildcard like.
Yeah. Okay, so we can do that.
Equivalent of that.
So another feature that we have with NATS top is you can do like pretty much like top, start doing sort on one of the fields that you have here. So you can sort on the messages. You can sort so that you can get the clients that we are sending the most messages to. So we have the first 5 clients receiving the messages. So far we have sent 1.5 megabytes, millions of messages. So, so yeah, we have 5 times the traffic. So, so this is one of the use cases from NATS, just sending messages and broadcasting to many clients. So the next thing to show is like, well, interest use case is the request response. So I will stop these subscribers. I have one here. Yeah. Okay, so I will be creating one client that is sending 1,000 requests per second. So it's basically creating this 1,000 go routines and then sending 1,000 requests. And requests per second with 1 kilobyte. I'm going to make this verbose. So I have 2 clients, one that basically give me the more details of what's going on and one that doesn't. Yeah, and each one of the requests from this client is going to time out after 1 second, right? So you can see also subscription there, but there is nothing on the other side replying to our request. So all of the subscriptions are continuously just timing out, and that's why you continually see this 1,000 number in the subscription. So in order to like solve this, we need workers to actually be subscribing to these events and responding back. So right now, basically, the system is broken. So let's add one request worker, and you would see now that things are much better. So you're sending 1,000 requests per second. There is barely any inboxes remaining. And you see a latency, I mean, locally in my computer is around less than 200 milliseconds for each one of these workers to reply. And this is around 2,000, well, 1,000 messages per second, but it's request response, so 2,000. So let's see what happens if, okay. So if I create more of these, let's create another 4. That's requests per second, 1 kilobyte. So yeah, there was an initial burst when all the subscriptions just piled up, but the system is continues to work perfectly fine. And I mean, we have some subscriptions piling out sometimes, but it's still sending. Well, now it's really working. Well, it's working more than I have Go Max Procs to 3 right now. So you can see it's already using more than 100% CPU, and so it's putting it to work. And right now, the worker, it is not using, each time that we increase one of these workers, it is doing something, basically all the events are being broadcasted to each one of these workers, and the fastest one to reply is what we consider to be the response from the client side, right? So this means that if we add more of these, we're basically multiplying all the traffic, so we're generating more load. And there will be, for this use case, I mean, it looks like, I mean, considering the response times that we're getting from the client, is now it's on 400 milliseconds. things would be much better if we start using a distributed queue. So with a distributed queue, if you add more of these request workers, basically instead of being broadcasted, only one of them will receive the event, and so it allows you to do like load balancing about them. So I will change the kind of workers that I have right now. This one is the client. Requests. Okay, so system is not working right now. So I will create 5 of these. Workers. Queue. So now there's a single client sending these 1,000 messages, but it is being distributed to the queue now. So this one will scale much more, but we still have this 200 milliseconds delay happening right now. So there's another trick to make it this even more faster, which is by throttling a little bit before sending each one of the requests. So now by throttling a little bit before sending the request, we can get a response time of less than 400 microseconds now. So this is way faster and better user experience. Well, the system works better this way. And just to show more about NATS stop, we can do, by pressing N, you can make queries to the monitoring server to give you, for example, like the top 1 or the top 3 clients that have sent the most bytes from. So that was basically it. Yeah. So this is N, give me 10 connections with the most messages. 4. You can see all the options with pressing question mark, like top. Yeah. So these are some of the basic usage from NATS, and so now we can do some Q&A, and this is that's it for my demo, and yeah.